Okay. Okay, I hope you scan it. Okay, let's check. Okay, so yeah, welcome. I think we have more students that's now in Taiwan, right? Maybe two more students or three. Yeah, Andres is in Taiwan, right? And do you know others? Not yet, right? Or maybe still in the quarantine. Quarantine. And other ITP also quarantine, right? Except some. Okay, how do you feel arriving in Taiwan? The other dorm. Which dorm you are in? The left one or the right one? Yeah, that's the old one. Yeah, I think I'm not sure whether you can apply for change your dormitory. I think you can, but yeah, that should be next year. Yeah, I also used to live in that dormitory as well. I live in the 14th floor. Yeah. Uh, a few years ago, it's just a normal room, uh, four students, one room with bathroom inside. Yeah, yeah. They changed the room now. Okay. Uh, so actually, today I just want to explain a little bit of the trigonometric, but I will explain first what we will do in the class, okay? Because this class is actually a PBL class. I'm not sure you are familiar or not, but let me explain for you. So I hope the online students can hear me as well. So PBL, okay, let me write PBL. Okay. Uh, Sometimes it's written like it's a project or a problem. Sometimes they have these two definitions: uh, base learning. So actually, what we will do with this PBL, it will be uh, you will do your own project or your own problem, and I think we can start at the beginning of or maybe at the end of November or at the beginning of December. Okay, between those two, I will announce to confirm which time. And the PBL means that the students need to be in, involved in the learning more than as usual. So usually in every uh, mathematics or any science classes, usually teacher will teach and then students will listen, right? But now for this PBL, I will try to involve students more. So I will have you guys to do some some topics, okay? The topics it can be about but it should be related to mathematics, okay? It should be related to mathematics. Maybe I will write in the notes here so that the online students can also see. Okay, so let me write here. Okay, so PBL. Okay, so it can be about it can be about a project, uh, problem, uh, based learning. So the purpose is to involve students to be more active. Okay, now the topics that uh, I can show you, for example, okay, some parts in trigonometry. For example, this is just an example. Okay, you can look for another topics if you want. For example, some topics in trigonometry, they require some, how to say, the identity, right? Uh, of course, not just like the basic one like you already seen. There are a lot of identity, and for example, you can apply uh, some topics related to this identity. Maybe first you can define what it is, and then prove the formula. For example, this is just example. Prove formula, and then how you apply. And I will give you like big topics just for you to choose so that you can follow the topics. But each student uh, will have different topics. Okay, so I think we because we have four, four, eight. Usually we have 10 students, if I'm not mistaken. So 10 or 11 students. I forgot. So I will prepare at least, okay, at least in our case, probably 10, okay, and it will be based on our topics in the textbook. Okay, you have the textbook, right? Okay. So uh, as soon as you are not submitting, propose your topics, you will get. So it should be the one who talk to me faster, then he or she will get the topic. Okay. For example, you want the topic about the logarithm, and then you ask me first, and because no one had that topic before, you got that topic. Okay. Okay. So please wait for the official announcement. Maybe the end of this week, I will announce like which topics that you can choose, and again, uh, you will have, for example, we will start the class, this PBR class on PBR class. It's if not end November or first week December. So we will have at least, okay, 3 to 4 weeks. Okay, and I will prioritize the topics that we haven't covered yet in the class. Okay? So the idea is for you to pursue that topic, okay, and then uh, the report. Usually, the report I will, so it will be required here. So you also to prepare the report. But because if you if you see report like written text, you write, or maybe using a computer. A lot of courses already doing that. My report, I'm preparing to prepare the at least a video. Okay, at least you guys have a smartphone, right? And you guys can help each other. Like maybe your friends can help you to take video. So the video will be includes the details of your topics. Okay, for example, you define and then you like give some speech about that topics. Okay, and I hope it's similar like when you are watching YouTube videos and then some tutorials, something like that. So you explain and then try to explain to maybe high school or junior high students. So explain with the simple words that they can understand. Okay? So I will try this method to actually to help you to sometimes if you thinking you need to study in the class every time, listen to your teacher, listen to your lecturer, uh, you just listen in one way. Okay? But if you're doing this, you'll have at least twice effort. You try to understand and you try to apply. So basically, in theory, it should be better. So that's I want to try. So this is also can help you to uh, at least the final exam score. Some percentage will be based on this. So this will help your final exam. Okay. So that will be about the PBL class. If you have any question about this, you can ask me later. Okay. And I will give you maybe some reference examples, like maybe one or two, how you can make the video or maybe making the concept, the content inside. Okay. And do not make the content too similar with the textbook, with any textbook. So we can do your own creativity. Okay, you can do your own creativity. You can take some approach to anything. If you want to relate that to video games, it can be. It depends on you. It depends on you. Depends on you. You want to relate with your real life situations, buildings, anything, technology, anything. Okay, anything. Okay. 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 Before we go and to the next sections, I will have some feedback. Okay. So this is, I think, just to remind you, okay, what is the even function, odd function, or neither from yesterday. Um, how to check even or odd. Okay. So if you have the functions and you plug in the negative part of it, the negative x, if this bring back the original equation, this means the function is even. Okay. If this making it's negative of the original functions, this will be odd. If this is not giving anything like this or even the same as this, then it's not even or odd function, so neither. So first we can check the negative. Okay. This will be negative x, and then the sine will having okay, sine negative x. Sine negative x equal to, if you remember the yesterday class, it's equal to negative sine x. Okay. Do you know why? Because it's quadrant 4. Okay, quadrant 4. So remember quadrant. Okay, remember quadrant. This is 1, 2, 3, 4. Okay. So I will write which one is positive. Okay. So this is all positive. This is sine positive. This is tangent positive. This is cosine positive. Other than that, they are negative. Okay. So cosine in quadrant 4 is positive, and quadrant 4 is when you have uh, the t, remember the reference number, when you have the reference numbers going clockwise here, this will be negative t. Okay. So that means if you have this negative x here, this is similar with what we have in reference number, our negative t. So it means it's on the quadrant 4. So it becomes negative sine x. And you cube this negative sine x, and it will be negative, right? And negative, uh, negative, it will be, let me write here. So f is negative x, negative sine x, and then cube. This will be x sine. It's bring back the original equation. So that's why it's the even function. Okay. Okay. That's the first question. Okay. This quadrant 1, 2, 3, 4 is I think better you keep in mind because you will maybe always looking at these quadrants also in calculus. Okay. The second question. Okay. The second question. The question from the information given, find the quadrant in which the terminal point determined by t lies. Okay, so you need to find which quadrant. You have cosecant positive, okay, and secant negative. Okay, now let's draw the quadrant. This is 1, 2, 3, and 4. Okay. Now cosecant is 1 over sine, secant is 1 over cos, and how the sine will looks like, it will be the same, right? We'll with cosecant will have the same signs with sine. The secant will have the same sign with cosine, right? Okay, so we know that cosine here is positive and sine here is positive. This is all positive. This is tangent positive. Okay, now look here, we have sine that is positive. So cosecant also here, right? And secant, they could be here also, right? Because cosine in quadrant 2 is negative. If we check others, there is no other possibility. Sine, this is negative here, so also cosecant also negative, secant is positive. Here, the other one will be negative, so cosecant also negative and secant also negative. So the only one that is possible is the quadrant 2. So that's why the answer is quadrant 2. Okay. Okay. And the last one, okay. The last one is, this is remember, this is x, y. Okay. Uh, tangent tangent is y over x. Let me write all. Okay. Tan t is y, cos t is x. Okay. Because this is important when we learn later about the polar coordinates. Find tangent theta. So y over x. So 2, 5. This is square root of 5. This is just 2, right? Okay, just 2. So the answer is 2. Okay. Okay. Let me continue a little bit about the this trigonometric. Okay. Now, the sections will be about the inverse. Okay. So I'm skipping some parts that I think no need to dwell or to get in touch with that part. Okay. So I will go to skipping and then go to inverse trigonometry. So actually, I'm skipping the cosecant, secant, tangent, cotangent. There's some sections about this one, but I'm skipping that. Hopefully, you can learn by yourself about the secant and tangent, because the principle of trigonometric is only about sine and cosine. The rest is the it came from the sine of and cosine. Okay, inverse trigonometric. Okay, let me start with the uh, the inverse of sine. Inverse sine. Okay, let me draw this sine. Okay, this sine will be here. Okay, more or less that is our sine. So this is y equals sine x. Okay. Okay, remember, if we take the horizontal test, okay, the line will cross more than one of the functions, right? Okay, which means this means that this is horizontal test to check functions one to one. If there is more than one, which means it's not one to one functions. But eventually, as you may know, then I've already explained before, that if we make some restriction on our domain here, so this is negative pi over 2, this is pi over 2. So if we make a domain only from negative pi over 2, then we will have only this part of curve. And if you check this horizontal line, it's exactly 1. Okay, it's exactly 1. So it means that it's one-to-one functions. Okay, let me write here. So y sine x on interval D or domain D is 1 to 1 function. Okay. Okay. Now, if we remember, sine pi over 2 is equal 1. Okay. The inverse, which means we reverse the domain and the range. Okay. So we can write this, right? Okay. So eventually, if we are going to draw, let me draw first and explain. So this is 0. Let's say this is negative 1. This is 1. And maybe pi over 2 is here. And negative pi over 2 is here. The sine inverse 1 is pi over 2, maybe around here. And sine inverse negative pi over 2 will be here. And if you check all the point here, okay, you can check the sine inverse half. This will be what? Pi over 6. Right? So maybe that will be around, so half is here, and pi over 6 maybe around here. So this will be, you got this. Yeah, around like that. Okay. If you look, okay, if you look here, it's pretty much, remember, every inverse, if you look here, let me draw a line here. This is just y equal x. Okay, this is y equal x. Every inverse is actually the result of the mirror of this the functions. Okay, if we mirror this through this line, okay, through the y equal x, this will be resulting. Okay, and if you see from what we have done here, it's actually pretty similar. It's a little bit different because I make different scales, different proportions. But if you see the green one here and hit this one, it looks like the same. Okay, if you check this, if you check the mirror with this one, you will get this, which is if you go through, it will going into our sine. Okay, so you can do every time you check the inverse and you have the graph. What you can do to check the functions, the original functions, you can mirror with the y equal x. Okay, so let me write here. y equal x, uh, every inverse is result of uh, reflected curve y equal of x about the curve, the line y equal x. Okay, so the inverse functions from here, we can define that inverse sine is the function sine inverse with domain start from -1 to 1, and range will be from, this is range, -1, negative pi over 2 to pi over 2, and defined by, you can also write this as arc sine, or e with without e, or yeah, I think arc sine. And remember, in inverse, you can have this cancellation sign, sine inverse x, this will be x, and then sine inverse sine x, this also will result in x. This is from, okay. Okay, you can do the same thing with cosine, cosine inverse. The difference will be in domain and range. Okay, remember, because the sine and cosine is complementary, if you look, the sine is from -pi/2, the cosine will start with from the 0. Okay, start from 0, 0 to 2 pi. So yeah, so if I draw the cosine inverse, let me just draw a little bit, and you can conclude by yourself. Okay, this will be the cosine, and this will be the cosine. It's not really that smooth, so I hope you can understand that. It's the shape is actually similar with the sine inverse, but it's just taking into different directions. Okay, the last part on the inverse is the tangent. The last part is the tangent. And don't forget, I think on maybe 4 or 5 p.m. or maybe 6 p.m., please check the Google Classroom. I will have this announcement about the quiz. Okay? Quiz about the exponent and logs. Okay. You still have time. Okay. Until the 22nd November. 22nd November. 22nd November. I'm setting the schedule for the deadline will be around 7 p.m. So you need to do before that. Okay. 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 The last part. Okay. Last part for the inverse is the inverse tangent. So tangent inverse x And if you remember the tangent, the original tangent, at pi over 2, they will have an asymptote, right? At every maybe let me make a really good scale. Negative pi over 2, maybe negative pi here, 0, pi. Okay. Maybe take elongated there. Maybe another point, another point. Okay. The graph will be, that will be the tangent. And we will have at least several of them here. Actually, a lot of them. At every periodical, okay, it will have the same property. They will have uh, asymptote here and there. It's not too smooth, but I hope you can understand from the graph here. So this is y equal tangent x. Okay. Now if you look here, of course, okay, of course, this is pretty much obvious that we can set up our functions only on from negative pi over 2 until pi over 2. And then we can set up the tangent inverse. Set up the tangent inverse. And making the, let's say this is the pi over 2 now here. And this is negative 1, negative 1. And let's take the asymptotes here. Okay. And this will be taking yeah, it's actually similar approach with this. If you take the y equal x, I think it should be here. Okay, I'm not drawing really properly, so it should be going to. Uh, so this will be how it looks like. Okay. I hope you can see the similarity. Okay. Okay. The purple one here. Okay. It should be going to have the same shape. Okay. It looks different because the scale are a little bit different. Okay. Okay. The other one is the secant, cosecant, cotangent. I think I will left that for you. Okay. Um, it will be interesting because on the if you check the secant and cosecant, the graph will be like this. Okay. The graph secant will be like this. The cosecant is the opposite side. And the inverse will be also interesting. This is only this part and this part. Okay, but I think I will skip this for now and leave it to you. And then the other part, after the inverse, this will be about the simple harmonic. I think it's pretty similar with the one in physics. Okay. So I would just review this, not really in detail. Just give you a glimpse on what it is. So it should be about the how to write the formula is using sine, and then you have the omega and the difference between the angle, and then plus b. Or you have, it can be also take the form in cosine. Okay, so if you look at this, okay, and you remember transformation, so this b will be a vertical shift. Okay, this b will be, b is a vertical shift, and this this one here is the horizontal shift. Okay, and this a will be the amplitude, okay, the stretching of the curve. Okay, okay, but I think I will not going into details about the simple harmony. This is to show you that the idea of our trigonometric function we can write in terms of uh, amplitude. We have the omega here. We have this the difference in the angle, and the applications with this simple harmonic is a lot of applications. We can apply this for uh, simulate the wave. Okay, also the electromagnetic pulse. Um, I think if you learn some courses in electrical engineering, you will going to look at this formula, and then they will be having more details in the formula. You will learn phase, how the difference between the uh, impedance, and then and so on and so forth. The one you learn in physics is just it just it's just the surface. Okay, there's a lot of applications here, but I think I will not go into details. Okay. If you want to look more like maybe give some approach to these topics, you can check the it's called the dampened harmonic motion. You can check this. Also the about the phase and phase difference. You can also check. Okay, what's that's about. Okay. Uh, okay. But I think I will not go into detail about this modeling harmonic. And I think for unit circle that it is okay, the necessary points. Okay, so from the first one we going to get some approach from a circle equations, and taking into trigonometric approach, and we got a trigonometric function. Uh, and after that, the so this is chapter 5. I said chapter 5. So chapter 6, right after this one, is the still trigonometric, but we are looking at the right triangle approach. right triangle approach. Okay. Okay. That this one will be. I think next week I will going to get into this right triangle approach. But some of the specific subject on this right triangle approach, I will skip and leave that for you to explore. Okay. Uh, so I will be a little faster now to make it 5, 6, 7, and make some points so that you can have some exploration on your own, and we can have a review which part that you are maybe still having a problem. Because I believe trigonometry is uh, one of the biggest problem in math, okay, and also calculus. Okay? Because if you don't understand the part conceptual part in trigonometry, you will have some difficulty in calculus. Okay. Okay. So okay. Okay. So right triangle. Okay. Let me check the uh, what we still have for our lecture. So first is chapter 1, fundamentals, functions. We have done that. Polynomial and rational functions. We have done that. Exponential, logarithm. Yeah, we have finished that. And trigonometric unit circle. I will. For now, it's finished, and then we are going to chapter 6, trigonometric right triangle approach, and then I will write first here, okay, so you can see what part we have left in our lecture. Uh, this is the analytic trigonometry. Chapter 8 is polar coordinates and parametric equations. And chapter 9 is vectors, 2D and 3D vectors. Chapter 10 is this is system of equations and inequality. This will be related to linear algebra, important if you want to learn more about programming, matrix, basically matrices. Okay, this will be heavily subjected on matrices. Between these 6, 7, 8, 9, 10, the one that I will teach personally, I think will be around the 8, 9, or 8 and 10. Okay, probably that part. Okay, the other part I will just give simple simple point. Okay, and then leave you to the part for some exploration. So our courses will be when we have reaching the when we have chapter 7 maybe finished, and we are going to have the chapter 8. We are going to have our class will be in a PBL class design. So we will have a schedule for you. So please wait for announcement this week. Okay, I will announce like about the topics, and then how about the other procedure, technical, like how you are going to write your report or making the video and so on and so forth. We will have a schedule. So we will have schedule. For example, you can find maybe you want to find or you want to explore polar coordinates. Okay, and then uh, maybe in the first week of December, I will have randomly uh, uh, check the students in order, and every week you need to be prepared to to explain, okay, in class in front of your friend. Okay, maybe just 10 to 15, or maybe to 20, and then have some discussion, and then I will the rest of the class I will fill in the details or maybe giving you more examples on the topics. Okay, so that will be our PBR class. Okay, and for the online students, you can prepare also some presentation. I will also giving you chances. So I will give you the chances to, so your screen will be appear on the class. So just so the students in the classroom also can see the topics you are going to explain. Okay, and about all the procedure, please wait for this weekend. Okay, so that will be our class for the PPR class, and I hope that will be around 1 month. So maybe on December, maybe 3 weeks or 4 weeks, 3 or 4 weeks we will have doing that. Okay? Of course, I will also uh, grade your results based on your performance. Okay. Okay. So, and I hope that will help your score. Okay. Okay. So I think that will be the end of our course. There will be no feedback today on today's class. Okay, because I will just mentioning this the PBR class. Okay. Okay. So okay. Any questions first? Any questions? Maybe you are have some interest on some topics. Online students, do you have any questions? If no, please wait my announcement. And if you finish your quarantine, but I think you just arrived later, right? And I think if you arrive at NTST on December, you still have chances to take some presentation in class. So we can wait for you. Okay. Okay. Any questions here? Mm-hmm. 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 Yeah, the topics I will announce. Okay, I will announce. Okay, which topics you are going to follow. Uh, Maybe you guys can have similar topics, but you need to have difference. Okay, you need to have difference. Maybe, for example, trigonometry, unit circle, trigonometry, maybe the triangle. It's different, right? Okay. Okay, I think that's it for today. Okay, thank you for joining the class and see you later. Okay, see you later. Yes, the basic math. Only 1 semester.